All right, section 7.7, we talk about how we can solve right triangles. And one thing we're going to learn is what is the inverse sine, cosine, and tangent, and how is it used. So to solve a right triangle means to find the measure of all sides and angles. And let's call this triangle A, B, C, and we're going to make it a right triangle. Okay, how we find the angles, we use what's called inverse tangent, inverse sine, and inverse cosine. That negative first power means inverse. So if we want to find the measure of angle A is right down here. Remember, from angle A, there is an opposite leg and an adjacent leg. And every right triangle has a hypotenuse. So, first of all, I want to make a comment here. You can write this down. To find angles, we use inverse sine, inverse cosine, and inverse tangent. Okay, and those buttons, to get the inverse, on your calculator you have sine, cosine, tangent. Inverse, you would hit the second button, and then you'd hit sine, cosine, tangent. So like for inverse tangent, you'd hit second tangent. All right, so the measure of angle A would be equal to the inverse tangent, which would be the opposite over adjacent. Okay. The inverse sine would be the opposite over hypotenuse. And the inverse cosine would be the adjacent over the hypotenuse. And by the way, this should be, I made a mistake here. This should be in parentheses. And you'll see what I mean when we go forward. Okay, so remember, sine, cosine, tangent, opposite, hypotenuse, and adjacent sides are used. So let's go ahead and show example 1. How is this stuff used? So use an inverse tangent to find the angle measure. So use a calculator to approximate the measure of angle A to the nearest tenth of a degree. So if you look at angle A, we don't know how big that is, but we do know that 16 is the opposite side and 20 is the adjacent. So opposite and adjacent would be the tangent. Okay, so the measure of angle A, to find angle measures, we do the inverse. So it's the inverse tangent, and then we do the opposite over adjacent, so 16 over 20. So on your calculator, the buttons you will hit is second tangent, and then you'll type in 16 divided by 20. And that'll give you the answer. You should find out that the measure of angle A is equal to 38.7 degrees. Again, because we're finding angle measures, you have to do the inverse. So the second button is what you use there. Okay, for the checkpoint, use the triangle from example 1 to approximate angle C. So if we use angle C, the opposite is now 20 and the adjacent is 16. So the measure of angle C is equal to the inverse tangent of, and let me draw a picture here. This might be easier to see. So 20 is the opposite and 16 is the adjacent side now. So for angle C, you would do opposite over adjacent, which is 20 over 16. So the inverse tangent, so second tangent, and then do 20 divided by 16, you would get 51.3 degrees. All right, so what if they don't give us a picture and they just tell us what the sine or cosine is? So like in the next example, they tell us, let angle A and angle B be acute angles in two right triangles. Use a calculator to approximate the measure of angle A and angle B to the nearest degree. And they say, well, the sine of A is equal to 0.76. How can you find out how big angle A is? So I'm going to rewrite this. Sine of A is equal to 0.76. So we want to get A alone. It's kind of like solving an equation. To get A alone, we have the sine with it. We have to do the inverse sine of both sides, because that will cancel out the sine. So we're left with angle A is equal to the inverse sine of 0.76. And then you take your calculator and you type in second sine 0.76. And you should get angle A is about 49.5 degrees. Same thing in part B. We want to get B alone. To get rid of cosine, we have to do the inverse cosine of both sides. So that will cancel out the cosine. And we get angle B is equal to inverse cosine of 0.17. Now you take your calculator, second cosine 0.17, and we should get angle B is equal to 80.2 degrees. So if they just give you the sine or the cosine, you do the inverse, and it will tell you the angle measure. All right, next example. Reminder, to find the missing side lengths, you can use trig ratios. You can use Pythagorean theorem. And just to talk about those, the trig ratios are the sine, cosine, tangent. And the Pythagorean theorem is a squared plus b squared equals c squared. To find the angle measures, we would do inverse trig, which is inverse sine, inverse cosine, and inverse tangent. And then the triangle sum theorem is just all angles add to 180. So look at example 3. It says solve the right triangle, round decimal answers to the nearest tenth. So we know that angle A is 23, and we know that angle C is 90. So let's start by finding the measure of angle B. So to find the measure of angle B, we know that the whole triangle adds up to 180. So the measure of angle B plus 90 plus 23 equals 180. So to solve this, you will minus 90 and subtract 23 from 180 to get the measure of angle B is equal to 67 degrees. So angle B is 67 degrees. Okay, and then we want to find AC and BC. I'm going to call BC X and AC Y. So let's start by finding AC. Okay, so if we use angle A, which that's the angle they gave us, so let's pretend we're at angle A. From angle A, the hypotenuse is 40, the opposite side is X, and the adjacent side is Y. So if we want to find out AC, AC is the Y side. That is the opposite. Oh, sorry, the adjacent. That's the adjacent side. We're going to use the adjacent side and the hypotenuse. So we're going to do the sine. Sorry, the adjacent side of the hypotenuse would be cosine. So cosine of 23 degrees is equal to y over 40. Okay, again, cosine is adjacent over hypotenuse, so y over 40. So how do we get the y alone? We would multiply by 40 to get 40 times the cosine of 23 degrees is equal to y. So if you type in 40 times the cosine of 23, you will get about 36.8 is equal to y. If you want to find out BC, again, using angle A, that will be the opposite side, and we're going to use the opposite side in the hypotenuse. So opposite hypotenuse is the sine. So the sine of 23 is equal to x over 40. To get x alone, we have to multiply by 40, and you would get 40 times sine of 23 is equal to x. So you take out your calculator and do 40 times sine of 23, and you would end up getting x equals 15.6. So we use sine, cosine, tangent to find those missing sides. Okay, example 4, solving a real-world problem. You are building a track for a model train. You want the track to incline from the first level to the second level 4 inches higher in 96 inches. So 96 inches they give us. We want it to go up 4 inches. That's given to us. These two sides in red. Is the angle of elevation less than 3 degrees? So if we want to find an angle, find angle means use inverse. So what we have, we're trying to find angle x. 96 is the adjacent side and 4 is the opposite side. So opposite and adjacent is tangent. So the measure of angle x is going to be equal to the inverse tangent of the opposite over the adjacent. So 4 over 96. So you would type in inverse tangent, so second tangent, and then do 4 divided by 96. You will get the measure of angle x is about 2.4 degrees. So is it less than 3 degrees? Yes. It is less than 3 degrees. It's 2.4. Okay, and then I will quickly show the checkpoints. To find the measure of angle D, if the sine of D is 48, we have sine of D equals 0.48. What we would do is the inverse sine of each side to get angle D is equal to second sine, so get inverse sine, times 48. Oh, sorry, 0.48. So if you do second sine 0.48, you would get about 28.7 degrees. Okay, and then checkpoint 3, solve a right triangle that has a 50-degree angle and a 15-inch hypotenuse. We're going to skip that one. Actually, we'll skip the next 2 checkpoints, and we will go through those in class. All right, I'm going to stop right there to keep the video under 15 minutes, and I will see you all in class.